Welcome to the Genius Factory. Enjoy the video.
You begin by preparing an isolated Python environment and installing TensorFlow, NumPy, OpenCV, and dlib if you need alignment. Next, download a pre-trained Facenet model checkpoint or a saved model. This gives you embeddings without training from scratch. Then, collect and structure labeled images into per-person folders. Quality and variety matter. Once done, run a quick image preprocessor to detect and align faces so each image matches the model input size, and then save aligned crops for embedding extraction. Now you load the Facenet graph and convert your aligned face crops into normalized float 32 tensors, subtracting mean and scaling as required by the model. Run the forward pass to extract 128D or 512D embeddings and save them alongside their labels. Once you have embeddings, build a nearest neighbor index with Fayes or Sklern's KD tree for fast lookup. Make sure to normalize embeddings to unit length. This improves cosine distance comparisons. Finally, persist the index and mapping file so recognition is reproducible and fast. For live recognition, capture frames, detect and align faces, then extract embeddings and query your index to find the nearest neighbor and similarity score. Decide a threshold from validation ROC curves and use cosine similarity to accept or reject matches. This balances false accepts and false rejects. If you see many false positives, increase threshold, add more labeled examples per identity, or perform hard negative mining. If false negatives persist, improve alignment, lighting, or consider fine-tuning the model on your dataset for better domain fit.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.